Professor Belfrost's science class is back.
Hi, welcome back to my class, and today we have another class, another lesson on physics, and this is on the eighth course of physics and this is the second video on the chapter of two-dimensional kinematics. Let's do some review from our last lesson. So as for one-dimensional kinematics, that we use arrows to represent vectors, and the length of the arrow is proportional to the vector's magnitude, and length is indicated by a hash mark in the figure, and its arrow points in the same direction as the vector. And this is the same for two-dimensional. So the path of an object is represented with three vectors. One vector shows the straight line path between the initial and final point of the motion. One vector shows the horizontal, and one vector will show the vertical component of the motion. Okay, and the horizontal and the vertical will make a right angle. Okay, so we can use Pythagorean theorem here. So there's a theorem of independence of motion that states the horizontal and the vertical components of two-dimensional motion are independent of each other. Any motion in the horizontal direction doesn't affect motion in the vertical direction and vice versa. So the two-dimensional curved path of the horizontally thrown ball is composed of two independent one-dimensional motions, and the key to analyzing such motion is called projectile motion. It's resolved to break it into a motion along the perpendicular directions. It is possible because they are perpendicular independent to each other. So analytical methods of vector addition and subtraction employ geometry and simple trigonometry rather than the rule and protector of graphical methods. So there are basically two methods. And analytical techniques and right triangles can go hand in hand in physics because motions along perpendicular directions are independent. And we very often need to separate a vector into the perpendicular components. And for example, give a vector like A, and we may wish to find which two perpendicular vector ax and ay, which will add and produce it. So the ax will be a cos theta and ay will be a sin theta. Okay, so that's for the lesson for our last lesson. And let's continue on the today discussion. So to see how to add vector using perpendicular components, that let's consider a figure below. So where vector a and b will add and produce the result in r. So if a and b represent two legs of a walk, then r is the total displacement. Okay, so actually can make use of uh, by analyzing first, by resolve it through the respective x and y component. So the equation, the magnitude of a is just square root of the sum of ax squared and ay squared, and the theta is the arctangent of ay by ax, and it's like before. So there are two steps that you can see here. So first picture to explain the step one, which is to identify the x and y axis that will be used in the problem, which ax is a cos theta, ay is a sin theta. Okay, so there are two vectors a and b, and also they have two angle, which is theta a and theta b respective. So step two, that is shown in the figure, the second figure. So we just add it. Okay, so rx is just the ax plus bx, and ry is the ay and by. Add it together. So components along the same axis are vectors along the same line and thus can be added to one another like ordinary number. The step 3 is just to get the magnitude by utilizing the Pythagorean theorem, which is the square root of the r squared and the ry squared. Also, the step 4 is to find the direction of the resultant, which is theta equals arctangent of ry by rx. So the following example will illustrate the tactics using by utilizing the uh, vector addition along the perpendicular axis. So here's the figure. So what we need to do, so factor R represents the first leg of wall in which a person walks about 53 meters in the direction of 20 degrees north of east, and factor B represents the second leg, which is displacement of 34 meters in the direction of 63 north of east. So how to solve it? That's very easy. So we have given the A and theta A, theta B, also B. So you just need to break it down. Okay, so we find the AX and BX using AX A cos theta and BX is B cos theta. And we find the AY and BY by utilizing the formula AY is A sine theta and BY is B sine theta. Then we add up the corresponding factor which is on the same axis. So the Rx is just the sum of AX and BX and RY is the sum of RY and BY. So Rx we obtain 65.2 meters and RY we obtain 48.4 meters. Now we can utilize the Pythagorean theorem to find the magnitude of the resultant, which is the square root of the previous squared. So R is 81.2 meters. And finally, the direction can be found by utilizing the formula theta is arcus tangent or Ry by Rx, which gives us about 36.6 degree. And we can plot them and analyze them using graphical method, and it will give us the same result. How about subtraction? Subtraction is just addition of a negative factor. That is, a minus b is a plus minus b. So actually, it's the same way we solve it. So Rx is basically just ax plus minus bx, and Ry is just ay plus minus by, and the rest is just identical. So here's the figure showing you how to do subtraction of factor. Next, let's learn a little about projectile motion. So projectile motion is the motion of an object thrown or projected into the air, subject to under the acceleration of gravity here, if we can neglect the resistance of the air. Okay, so the object is called projectile and its path is called the trajectory. Okay, so most important fact to remember here is that motion along perpendicular axes are independent and thus can be analyzed separately. So we need to break it into two motions, motion along the horizontal axis and another one is along the vertical axis. Okay, it's easy as before. So the figure, the next slide, will illustrate you the notation for displacement, where we take S to define the total displacement and X and Y are their components. And yeah, we have used SX. S can be broken up into SX and SY as before, but for simply we just take it to be X and Y. Of course, to describe motion, we must deal with velocity and acceleration. And here we take the acceleration on the y-axis to be the gravity. And gravity is just simply the, because we take convention that upward will be negative and downward will be upward will be positive and downward will be negative, then ay is minus g, which is minus 9.8 meter per second. Okay, so here's a review of kinematics equation for a constant a that we have discussed in the previous lesson, in the previous chapter I mean. So we can make use of this and create another set of equations. So step one, here the x is perpendicular, so x is a cos theta and ay is a sin theta. We still can make use of this. Then we know that the component of velocity phi are phi x is phi cos theta and phi y is phi sin theta. And the initial value is indicated by adding 0. Okay. So yeah, here's the picture showing you the projectile motion, and you can see that the phi x is constant, and phi y is only affected by the gravity. Okay, there's no other motion, right? And here we can derive the formula that needed, like x is x0 plus phi x t. If x is the same along the motion. Also ay we make use of minus g, which is minus 9.8 meter secant square, and also y is y0 plus half times phi 0y plus phi y times t. So like phi y is phi 0y minus gt, y is y0 plus phi 0y t minus half times gt square, and phi y square equals phi 0y square minus g minus 2g times the subtraction of the difference of y to y0. And this is just the same as the previous chapter. And step 3, we need to solve for the unknowns in the two separate motions, one horizontal, one vertical. And this is very easy actually. And step 4, we just recombine the two motions to find the total displacement s and velocity phi. So we just make use, we employ the previous formula. So yeah, a is just the Pythagorean theorem, and theta is just the Archimedes technique. So the total displacement and velocity can be summarized with these four formulas that I show in the slide. Okay, easy, right? To better understand the concept, let's discuss an example. So say that during a fireworks display that shell is shot into the air with an initial speed of 70 meters square and the angle of 75.0 degree above the horizontals, and a few times to ignite the shell just reach the highest point above the ground. So first you need to find the height at which the cell will explode. The second is how much time passed between the launch of the cell and the explosion. Third one is the horizontal displacement of the cell when it explodes. So yeah, by high we mean the altitude or vertical position above the starting point. So here the highest point is when Vy reaches 0. So it's simply just Vy squared equals V0 y squared minus 2g y minus y0. That is the formula that we'll utilize. But because we know Vy is 0, then we can simply make use of we can simply create another formula, and it gives us y equals the square of v0y divided by 2g. That's the formula that we'll make use of. Okay, so how to find v0y? So v0y is v0 sin theta. That is the formula that I've explained before. And by using this, that we obtain that y is 233 meters. And note that because up is positive, that the initial velocity positive, and s is in the maximum height, but the acceleration due to the gravity is negative here. Okay. To solve point B, okay, we make use of this formula here. So y equals y0 plus half times sum of v0y and vy times t. So we just need to rearrange it and create the new formula, which is t equals 2y divided by the sum of v0y and vy, and it gives us that t is 6.90 seconds. This is time before the firework explode. Okay. To solve for the third one, so because the error is negligible here, that ax is 0 and the horizontal velocity is constant. So first we need to find the Vx first. So Vx is just a V0 times cos theta, which is 70 times cos 75 degree, and it gives us 18.1 meters squared. And x is can be found by simply substituting it to the formula, which is Vxt. And Vx is 18.1 meters per second, and t is the previous t that we have found in the point B, which is 6.90. And it gives us about 125 meters in three significant figures. So the horizontal motion is a constant velocity in the absence of air resistance, and horizontal displacement found here could be useful in keeping the fireworks fragment from falling on spectators. So this is the consideration that we may make use in another problem. Okay. So now we also can find the maximum height of our projectile by only depending for a vertical component of the initial velocity, and this is given by h equals v0y squared divided by 2g. I want you to derive this formula by yourself by utilizing the formulas that we have found before, and I will not show it here. Let's dive into the example. So there is a active volcano in Hawaii called Kilauea, and this is very active. And suppose a large rock is ejected from the volcano with a speed of 25 meters per second and at an angle of 35.0 degrees above the horizontal, and strikes the side of a volcano at an altitude of 20 meters lower than its starting point. So first question is calculate the time it takes the rock to follow this path, and the second question is what are the magnitude and the direction of the rock's velocity at impact. So here's the figure showing you the problem. So let's solve it one by one. So first point is very easily done and it is self-explanatory. You need to make use of the formula y equals y0 plus v0 yt minus half times gt squared. So first find the v0y. This is v0 sine theta. and it is 25 times sine 35.0 degree, and it gives us about 14.3 meter per second in three significant figures. By substituting the value before, then we can create the equation and rearrange it. We can make use of the quadratic formula, and yeah, we find the solution, which is t can be 3.96 or minus 1.03. But the one that makes sense here is the positive time. So this is 3.96 seconds. That will be the solution to the first question. I mean. For the second question, we first need to find the px first, okay? And px is constant along the process of the motion. So px is just phi 0 times cos theta, which is 25.0 times cos 35 degree, and it gives us about 20.5 meters per second when we take three significant figures. And by using this fact, that we know that uh, phi x is known, phi y is also known. So phi y is simply phi 0 y minus gt, and the t has been found at the first first question. So we just need to add them factorically by utilizing the Pythagorean theorem, and we have the value of phi equals 31.9 meters per second. And how about the theta? The theta can be easily found by utilizing the Arcus-Tangen formula, and it gives us about minus 50.1 degree. It means that it strikes with a velocity of 31.9 meters per second with the angle of 50.1 degrees below the horizontal. And this is what we expect, right? So one of the most important things illustrated by projectile motion is that vertical and horizontal motion are independent of each other. Okay, so on a level ground, that we define rate should be the horizontal distance r traveled by projectile. Okay, and this is a very interesting discussion. So how does the initial velocity of projectile affect? Obviously, the greater the initial speed v0, then the greater the range, as is shown in the figure and the next slide. And also the initial angle theta 0 has an effect on the range, which will be illustrated in the figure B. So the maximum range is actually about 45 degrees if we can neglect the air resistance. But by considering the air resistance, then the maximum angle is about 38 degrees. And it always that the two angles that make maximum will add up to be 90 degrees. And here's the formula: R is phi0 squared sine 2 theta over g. And we'll see the example on our next lesson. So here's a quote for you today. So Martin Luther King Jr. once said, if I cannot do great things, I can do small things in a great way. So thank you for watching. Subscribe, give a like, comment, share this video to your friend. I'll be back every Tuesday and Thursday. Keep watching and be thoughtful. I'll see you later. Goodbye.